I'm going to now show you three different models in Stata that could be used when you are examining data across two time points. This first model shows a latent variable of depression and then some controls: income, number of children, race, and health risk. Also, time one of our outcome, marital quality at time one, predicting marital quality at time two. So this type of model is predicting time two, controlling for time one. And once I have this model set up, I can hit estimate. I'm going to estimate maximum likelihood with missing values because we do have some missing data. And once I do that, the output comes out here in the Stata software. It is fitting the model, and now it has fit the model. If I scroll up a little bit, here's my output. Okay. Basic information, number of observations 680. Here are my structural coefficients. So income, predicting marital quality at time two, number of children, race, marital quality, health risk, depression, and the intercept. Notice marital quality here is a significant predictor, but depression is not when you control for marital quality at time one. Here are my factor loadings for the depression variable, and I don't believe I asked for standardized coefficients, and so these are unstandardized factor loadings. And in fact, this one here is constrained to be 1. If we were viewing the standardized solution, that would not be 1. Here we have the variances in our error terms and our other variables, the covariances, and that's the output. Okay, all of these are the covariances between independent variables. If we move to our second example, where, let's see if I can adjust this down, where we have, instead of marital quality at time two being predicted by wave 1, we have marital quality at time 2 subtracting wave 1, and when we subtract that, we get a change score. So how much did marital quality change between wave 1 and wave 2? Generally, you get the same answer in the research, in your results from this type of a model and the last one I just showed you. We'll go ahead and run this. See that the model is running here. And here's our output. Our main interest being right here. And actually, so you'll notice the only variable that's missing now is marital quality at time 1 because it's captured in our dependent variable, and depression is still not significantly related. This is for the wife, by the way. Let's go to our third approach, which is a cross lag. Here we have depression at wave 1 and marital quality at wave 1, depression at wave 2, and marital quality at wave 2. We could add our controls down along here correlated with these predictors and predicting the outcomes. So I run that model. We see that marital instability predicts depression at wave 2, and depression at wave 1 predicts depression at wave 2 significantly. Marital instability at wave 1 predicts marital instability at wave 2. Depression at wave 1 also significantly predicts instability at wave 2. And so this gives us a little better sense of the reciprocal nature between depression and marital instability. Again, we would need to add controls to that model before we could publish it. And that's those examples.